Right, in this lesson we're going to be looking at distance time graphs and velocity time graphs. And we're going to start off with this straightforward question from Dr. Frost where we've got to draw, we're going to move these points around and create a distance time graph that describes this story for, I'm not sure how to pronounce that, Licia, and describe her journey. So she sets off from home. So this is the distance from home. And if she sets off from home, she's obviously going to start from 0. Let's just move that a little bit closer. And then we work out that she travels 35 kilometers in 15 minutes. So that's going to be 5, 10, 15. And she's going to travel 30 kilometers in that time. And then she travels 40 kilometers. So she's going to get to 70 the next 25 minutes. So that's 5, 10, 15, 20, 25. So 40 minutes. She'll be 70 kilometers away from home. And then she stays there for 25 minutes. So there is 25 minutes. If we go 20 plus 5 minutes. And she travels back home and arrives after 30 minutes. So 65, 30 minutes, that will be 95. So we go 95 will be just about there. And there we have it. We have the distance time graph that represents Licia's journey. Okay, moving on now, we're going to look at some other things, such as we're going to determine the exact distance from a velocity time graph. Now, in a velocity time graph, the area in a velocity time graph is this area under here is equal to our distance traveled. If you think about it, our velocity, if we have our velocity here and we times it by the time, that gives us our distance traveled. You should know that already from previous maths and physics lessons. Velocity times time will give you a distance traveled, and therefore it gives you the area under the graph. Now here we've got the velocities going up, so we can work out the average velocity for that time and times by the time, and that will also give you the area under the graph for that bit of the triangle. But the easiest bit to do here is just to turn it into a trapezium. So remembering that the area for a trapezium is equal to the lengths of the two parallel sides, A plus B, added together, divided by 2, times by the distance, which is often known as h, between them. So we can see that the distance here is going to be, now this is, each square is going to be 1 unit, so it's going up 1, 2, 3, 4, 5, 6, that distance is 6, and on the bottom we have 23. So A is equal to 6 and B is equal to 23. So the distance will equal 6 plus 23 divided by 2 times by the height between them, which is the velocity, 7 seconds. So we've got 29 over 2 times by 7, which gives us 101.5. Now look at our units, meters per second, so therefore it's going to be meters. Right, in this next one we have a curved frequency polygon, and Dr. Frost builds you up by showing you that actually what you do is you estimate it by taking these bands. So they try to divide it up into 2 sections, and they made this first section to a triangle and this second section into a trapezium, and we can work out those 2 areas to find the area under our graph. Now the height of this one, if each of these if that's going to be 25, this is going to be a height of 20. And this one is going to be a height of 80. So we have a triangle here where the base is equal to 2 and the height equals 20. So our purple area will equal 20 times 2 divided by 2, which is just equal to 10. And this one, remember, we did the 2 parallel sides times by the distance between them. So we got 20 plus 80 divide by 2 times by the distance between them, which is also 2. So this just comes out to be 100. So therefore the total distance is approximately equal to, because we used this triangle to estimate that area under that curve, and this trapezium to estimate the area, is equal to 100 plus 10. And we can see that this will equal 110 meters. And we can see that our estimate of the area is actually going to be slightly too much, because we've got this little bit here that's too much, and this little bit is too much. So if the question asks you if you're overestimating or underestimating, look at the area between the curve and the trapeziums and triangles you've drawn, and you will see whether you are estimating, overestimating, or underestimating. Now, in this question here, we have not been given the triangles and trapeziums, and we've got to work them out for ourselves. And we're going to do 3 strips of equal width. So if it's 3 seconds, each one will be 1 second wide. So let's put a triangle in here to start with. And then we'll put a trapezium in here. And then we'll put another trapezium in here. And the key thing is to work out our heights. So each one of these squares is going to be equal to 20, because that's 100 and there's 5 of them. So that's going to be 10. So that's going to be 20, 40 high. And our width is 1. So this one has an area of 40. Now this one is going to be 150 high. That goes through halfway through there. So that's going to be 150. So the area of this one here is going to be 40 plus 150 over 2 times by 1, which equals 190 over 2, which equals, we call that area B. Area B will equal 95. We call this area C. We know that height's 150. We can see we're going to go all the way up to 340. So for area C, we're going to have 150 plus 340 divided by 2 times by 1. So that's going to be, what was it? That was 340. We got 150 plus 340, that's 440. 490 divided by 2 is 245 meters. So the total distance is going to be 40 plus 95 plus 245. So add that on, that gives me 250. Add on 90, it gives me 340. So that will give me 380 meters.